Alright, now that we talked about limits and we had ample time, I broke that into 2 sections for you instead of 1 so you really get a full grasp on it. Now we're going to go for some limit laws and use this shortcut that we're going to learn. So, let's make sure there's no confusion. How do you find a limit? You plug in numbers. How would a limit exist? If the limit from the right and the limit from the left equal. How would a limit not exist if the limit from the right and the limit from the left does not equal? Everything we're learning now in this section is pretty much rules for a limit instead of plugging the numbers, which is the original definition. Or of course you could look at a graph and say, but the same idea. When you look at a graph and you say, well, I'm looking from the left, that's approaching from the left. Looking from the right, the same idea. There are a lot of rules for a limit. In this class, it seems you could switch the order any way you like. That is, if I assume that C is a constant and these two limits exist, which means the limit as x approaches a from the left of f of x equal the limit as x approaches a from the right of f of x. Same with G. The rules are, there are more than 11 rules. For now, we're going to focus on 11 of them. If you take the limit as x approaches a of the sum of two functions, then that would be the limit, that would be the sum of the limits. So the limit of the sum of two functions is the sum of the limits. The limit of the difference of two functions is the difference of the limits. The limit of the product of two functions is the product of the limits. That's the type of wording I said you could in this chapter, you could in this class pretty much switch the order any way you want. If I'm taking the limit of a constant times a function, I could ignore the constant, take the limit of the function and multiply the result. Limit of the quotient of two functions is the quotient of the limits of two functions. And as you see, you could change the wording any way you like. Now, numbers 7 and 8. Now, you don't have to know those by numbers except for a couple of homework problems just for you to really grasp this, and when we go from there. If I take the limit as x approaches a constant, no matter what this is, it makes no difference. According to rule 7, that's the constant. So I'm going to circle 7. And I'm going to give you an example. If I take the limit as x approaches 4 of negative 3, what would that equal? Well, let's look at that graphically. That would be really quick to see. If I look at y equal negative 3, I would figure out quickly, I would figure out quickly that, you know what? No matter what x is, the y value is gonna be 3 no matter what. Whether I'm approaching this value, whether I'm approaching this value, right? And if I make a table, if I say, well, let's go about this the traditional way, x and negative 3. If x equal 4.01, y equal negative 3. If x equal 3.99, y equal negative 3 no matter what. So the limit of the constant is the constant. And the limit as x approaches a of number 8. Number 8 up there is by 8a. Again, if I look at this graphically, it makes a lot of sense. Y equal x, there it is. No matter which x value you pick, y is going to match. Right? So if I picked, for example, the limit as x approaches 3 of x, well, if I make a table, if I pick 2.9 for x, well, y equal x. If I pick 3.001, y would be 3.001. Do you notice whatever x is, y is? So you plug that in and pretty much you get that. I could also use 9. I really don't have to justify that from now on. I'm just gonna set those as my bases and go from there. Now let's look at some problems. If I start with problem number 2, so only on number 2 through 9. Only on number 2, and I know you can't see that, let me just move that, but here we go. Number 2 through 9, I would like you to justify which of those rules are you using. Only on those. You're not going to do that on a test. I need you to do that in the homework. So if I take A, for example, I'm going to say that limit is going to equal the limit as x approaches 2 of f of x plus the limit as x approaches 2 of g of x. Only on this section, I would like you to state that you used limit law number 1 to be able to do that. And now it's simply a matter of y values. We did that already on 1.1. There's the graph of f of x and there's the graph of g of x. If x is approaching 2, right? This is not exist, right? They don't have it anywhere. Yeah. So automatically, it doesn't matter what this is. Automatically, this does not exist. No need to do that. The second, in case you're interested on what that would be 2. But it doesn't matter. And if I take part B and take the limit as x approaches 0 of f of x minus g of x. So by me saying this is the limit as x approaches 0 of f of x minus the limit as x approaches 0 of g of x, on the homework, I would like you to quote that this was by property number 2. And the limit as x approaches 0, there's 0 of f of x, that's 2. The limit as x approaches 0, and do you see the limit from the left and the limit from the right don't match? So the answer would be does not exist. And if I go to part C, if I take the limit as x approaches -1 of f of x times g of x, that is the limit as x approaches -1 of f of x times the limit as x approaches -1 of g of x. And what allows us to do that? That's property number 4. And what's the limit as x approaches -1? There's -1. The limit from the left is 1. The limit from the right is 1. That's a 1. For g of x, -1 is right there. Limit from the left is a 2. Limit from the right is a 2. So that gives me a 3. If I look at part D, the limit as x approaches 3 of f of x over g of x, I would say that would be the limit as x approaches 3 of f of x over the limit as x approaches 3 of g of x. And what allows me to do that? That is allowed by property or law number 5. And what would that be? If I look at the limit as x approaches 3, there is 1, 2, 3 is right there. From the left is a 1, from the right is a 1, that is a 1. For g, there's 1, there's 3, 1, 2, 3. From the left it's 0, from the right it's 0. So I will get 1 over 0, and 1 over 0 means does not exist. And that was the condition on part D. If you look, I didn't elaborate on that because that was coming up right there. If you're going to take the limit, this limit better not equal to 0. If it equal to 0, this limit wouldn't exist. And if I go now to the last portions, E, what is the limit as x approaches 2 of x squared times f of x? And this is really what we want to start. 2 steps. Limit as x approaches 2 of x squared. This is where we're going to start really using those shortcuts. What says the product property for? And this is key. This is the limit as x approaches. This right here is 2 squared. And this right here, if I go to the limit as x approaches 2, there's 2 right there, you guys. Limit from the left is a negative 1. From the right is a negative 1. So this is negative 1. But what allows me to substitute this to n? Can you guess? What allows me to substitute that value n? Isn't that number 9? This is by 9. And the answer would be a negative. So I'm not after the answer for this. I'm after you learning how these techniques work. They're a lot more important than you think. And if I take f of negative 1 plus the limit as x approaches negative 1 of g of x, well, f of negative 1, that looks like an ugly f of negative 1. We want this to look pretty. Go to the f function. When x equal negative 1, y equal 3. And the limit as x approaches negative 1 of g, negative 1 is right there. From the left it's a 2, and from the right it's a 2. So that turns out to be a 5. If I look at them, to give you a page now, okay, page 70. If I look at the last problem for this video, that is, not the last one for this section, well, I want to apply again all the way up to number 9. It says, evaluate, justify each step. I would like you to really use the justification. This is not a test question, but it is a homework, and I want you to really spend time figuring that out. So the first step here, you're going to say, by rule number 4, the limit of the product is the product of the limits. Here, this is going to be the limit as x approaches negative 1 of x to the 4th plus the limit as x approaches negative 1 of negative 3x. What allows me to do that? That's rule number 2. Actually, rule number 2, I could take the minus up front. Same thing. I could have said 1 by plus times here the limit as x approaches negative 1 of x squared plus the limit as x approaches negative 1 of 5x plus the limit as x approaches negative 1 of 3. This is allowed by rule number 1. This is allowed by rule number 1. This is the limit as x. Actually here I'm gonna use direct substitution. I'm gonna say that's negative 1 to the 4th. Step 9 allows me to do that. I'm gonna take the 3 up front. I could do that in one step, but I'm gonna do it in 2 just to see it. And this is 1. This is minus 3. I'm gonna throw the 4 in there. And what allows me to plug the 4 in there? That is property number 8. So this first set of parentheses is actually 1 minus 12, which is negative 11. As for the second piece, I'm going to substitute that in. That's going to be a negative 1 squared. That's by property number 9. I'm going to take the 5 up front, limit as x approaches negative 1 of x. This is allowed by property number 3. And this last portion is a 3 limit of a constant. I proved that for you. That is by step number 7. And that's going to be 1 by algebra. This is 5 times, you're going to substitute a negative 1. What allows me to do direct substitution? That's number 8 for x plus 3. And that turns out to be 4 minus 5, which is a negative 1. So altogether, this would be an 11. Okay, I'm gonna stop this video here. I'll pick this up on the next.